This is Miss D again. Today we'll be exploring how to model hundredths. So let's get started by looking at slide C. Think back to slide B to help you tackle this problem. Let's read this together. So here we have a meter stick, and it gives us information here that 1 meter is equal to 100 centimeters. And it also has a tape diagram that is divided into 10 parts. And it tells us that 1/10 of the meter, so one of these shaded boxes, is equal to 10 centimeters. And 1/100th of a meter is equal to 1 centimeter. We know that because 1 meter is equal to 100 centimeters, so 100th of that meter would be 1 centimeter. So here it says 1/100th is written as 0.01. How do you think we write 3/100ths of a meter in decimal form? And you also have some questions here. Look at the model above. What do you notice? What are you wondering? So go ahead and answer those questions, and when you're ready, you can unpause. So how did you write 3/100ths as decimal? Did you use that information that was given to you in this box to kind of help you out? I thought it was pretty important to pay attention to this sentence here. It gave us a clue here. It said that 1/100th, which we write like this, is equal to 0.01. So knowing that should have helped us figure out how much 3/100ths would be. So what did you get? Did you write it as 0.03? If you did, great job. So thinking about how do we write this, we kind of have to think about our place value chart. And the 0 here is in the ones place. The second 0 to the right of the decimal is the tenths place, and then the 3 is located in the hundredths place. Since the only digit we have here is the 3, we'll read it as 3 and then name the rightmost place value, which is hundredths. So 3/100ths. So what did you notice? What did you wonder about this model above? Did you notice that 1/10 of the meter is shaded? Did you wonder how we would show 3/100ths on the meter stick? Yeah, that's what I was wondering too. Let's go ahead to the next slide. So here on slide D, we have that same model. So we have that meter stick, and it's reminding us that 1 meter is equal to 100 centimeters. Now we have the model, the tape diagram, being divided into 10 parts, but the first part that's shaded is broken further apart into 10 additional parts. So it says here 1/10 of a meter is 10 centimeters and 1/100th of a meter is 1 centimeter. How many hundredths of a meter equal to 1/10 of a meter? How do you know? Look at the model above. What do you notice? What are you wondering? So go ahead and answer those questions. So you can go ahead and pause, and when you're ready, you can unpause. So what did you think? How many hundredths of a meter are equal to 1/10 of a meter? How do you know? Well, think about it. That 1/10 is this portion right here. And if we think about it, if we divided all these other 9 parts, like this first part, we would have gotten 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So we would have gotten that denominator of 100 because we would have 100 parts. Now, how many parts are shaded here? 10, right? So this first part shows 10 hundredths. So 10 hundredths or 10 1/100ths are equal to 1/10 of a meter. I know, since there are 10 parts for every centimeter. So here, looking at the model, what did you notice about this model, and what are you wondering? Did you notice that 100 centimeters equals 1 meter? Did you notice that each centimeter is equal to 1/100th of a meter? Did you notice that 10 centimeters is equal to 1/10 of a meter? Great observations there. Let's go ahead and explore the next slide. So here we have that same picture and tape diagram. And it gives us that information again here, but in the box. So it says 1 meter is 100 centimeters, 1/10 of a meter is 10 centimeters, and 1/100th of a meter equals 1 centimeter. They want us to use this tape diagram above to shade 2/10 of a meter. So think of it as 2 out of the 10. And they also want us to shade in 5/100ths of a meter. And then finding how many hundredths of a meter are shaded in all. So go ahead and pause to answer this question. When you're ready, you can go ahead and unpause. All right, so let's go ahead and take a look at this question together. So this first part, they wanted us to just shade in 2/10. So they want us to shade in 1/10, then shade in another 2/10. And now they want us to shade in 5/100ths. Now, if you remember from the previous slide, we saw that they showed 10 hundredths. And the 10th was broken up into 10 additional parts so that we can talk about hundredths. So that's what I'm going to go ahead and do. I'm going to do my best to kind of draw here 10 parts. Okay, so now I'm going to go ahead and shade in that 5/100ths. So it says how many hundredths of a meter are shaded? Well, we know it's 2/10, and we know we're adding also the 5/100ths. But if you remember from earlier on the year, when adding fractions, we need to add fractions with like denominators. So you'll notice we have a denominator of 10 and a denominator of 100. What we're going to want to do is find an equivalent fraction for the 2/10. So we're going to have to change the name of 2/10 to hundredths. So I'm going to do some side work here, and I want you guys to work along with me here. If we need to change the 2/10 to hundredths, what are we going to do? Well, thinking about, okay, I need to get the 2/10 to hundredths. What do I need to do in order to go from tenths to hundredths? And what I need to do is I need to multiply the 2/10 by 10/10. And the reason I'm multiplying it by 10/10 is because I'm not changing its value, right? Because 10 out of 10 is a whole. And remember that the identity property of multiplication says if you multiply a number by 1, you're going to get that same number back. So we're not changing the value. We're just trying to rename it in a way that will help us to add these two fractions up. So I need to do 10 times 10 to get to 100. So whatever I do to the denominator, I have to do to the top. So I get that whole number here. So 2 times 10 is 20. So now I can go ahead and change this sentence slightly to 20 hundredths plus 5/100ths. And the reason that they're equivalent to is if I took these two parts and I broke them apart into 10 parts each, well, now I have 10 and 10 more parts. And then the 5 more parts would give us the sum, right, the answer to addition problem of 25 hundredths. So let's go ahead and take a look at this sample from student A. So I want you to think about what do you notice and what do you wonder that this student did, and also what does this make you think about decimals. So go ahead and answer those questions. You can go ahead and pause, and when you're ready, unpause. Okay, so what did you notice? Did you notice that they shaded 2/10 of the stick, and then they shaded half of the third? Did you notice they found an equivalent fraction for the 2/10, which is something that we did on the previous slide too? Were you wondering initially why we needed to shade half of that third part? Did you think why they had to find an equivalent fraction? Remember, when we add 2/10 plus 5/100, something that sometimes students make the mistake of is just adding the numerators, and 2 plus 5 and getting 7/100. Be careful. You need to make sure that your denominators are the same. So that's why the student found that equivalent fraction of 2/10 and renamed it to 20/100. Did you wonder why they shaded only half of the third part, or why they found an equivalent fraction for 2/10? What does this make you think about decimals? Does this make you think about the relationship between decimals and fractions, and that there are two different ways that we can represent parts of a whole? Well, great job. Let's go ahead to slide G. So again, it wants us to use the model above to determine the total of the shaded parts. And it wants us to write our answer in both decimal form and fractional form. So go ahead and answer this. When you're ready, you can unpause. All right, let's go ahead to look at how this student here tackled this question. So I want you to think, what do you notice? What do you wonder? And then what does this make you think about decimals? So go ahead and answer those questions. When you're ready, you can unpause. Okay, so what did you notice? Did you notice that they named the first part as 1/10 of a meter? Did you notice that they named the second part here, as 3/100ths? And did you notice that they added both of those fractions up and got 13/100ths? Did you notice that they renamed the fraction as a decimal and called the shaded portion 13/100ths, right? 0.13 meters. What did you wonder? Did you wonder why they decomposed the decimal? Did you wonder how they added unlike denominators? So you see here that we don't see that step from the previous student. Remember how we can't add fractions with unlike denominators. So we would usually write the step of 1/10 times 10/10 so that we can get that denominator to be 100, and we get that numerator to be 10. So if we add 10 hundredths plus 3 hundredths, we get that 13 hundredths. And finally, what does this make you think about decimals? Maybe that we can write a fraction as decimal when the denominator is 10 or 100. So when we have tenths and hundredths, it can easily be written as a decimal. And we see that relationship here. One of the things that I would really like you to notice too is that we see that number 13 here in the numerator, and we also see that 13 to the right of the decimal point. So just keep that in mind. Well, we've come to the end of this video segment. I hope that this has helped you at looking at how to model hundredths. Great job. I'll see you next time.